All right. So let's keep things moving, and we will bring up Jesse Martin, developer advocate at Hasura, to talk about streaming events versus live queries and taking a deeper look at subscription patterns. Jesse, how's it going today?
Going good. How you doing?
I'm excited to hear all the amazing stuff that's being shared, and I can't wait to see your presentation.
I'm excited to try to get through it. So I'll just jump right in here. So hey everybody, and I am Jesse from Hasura. I'm also fighting a cold here, so if you hear any of the nasalness, I apologize, but I will do my best to get through this. But quick going into this, I want to give a quick update of who I am. So you can find me, I guess for now, at Twitter at MotleyDev. Who knows what the future has in store there. But I'm a former brand guy and been mostly on the product side of things for a long time. So a lot of my talk is going to focus a lot about the product implications of GraphQL, and in this case, specifically on streaming. But I've also been a GraphQL educator for about 5 years now. So there's a lot of background. There's a lot of war stories behind some of this feedback or some of these observations that will probably come out in some of the stuff that I want to talk about. But I just wanted to give you sort of a context about the perspective that I'll be bringing on this topic. But specifically, we're looking at subscription patterns and sort of how they're implemented. And we're going to see a little bit why we see so many flavors of subscriptions kind of arise in the GraphQL ecosystem. And it's mostly having to do with the specification not really telling us what else to do. So I want to talk about Hasura real quick. I promise I won't make this very vendored. So what does Hasura do? If you haven't heard of it, we are a GraphQL company where essentially what we do is we will take your data sources and we'll stitch that to a GraphQL API. So whether you're bringing a database or REST APIs, or even wanting to bring in an existing GraphQL API of your own, you can bring those all into a single GraphQL API. We have really robust permissions, and you can put it together. Kind of the core of what the Hasura experience is what's called the Hasura GraphQL engine. And essentially what we do is we'll take a GraphQL query, we'll break that down into SQL statements ultimately, and then fire that off against your underlying data sources or whatever the underlying data source is you may have. There's a number of helpful features in there that allow us to make that really performant and really fast for you. But kind of this is where it sort of sits in the ecosystem of your features. You'll see that I'm kind of rushing through this because I want to just give you the overview of sort of where our streaming experience is coming from. But you'll see the Hasura sort of sits in between this part where all of your additional data sources come together. And then we have some authorization that sits on top of that. We have all of this information online, so definitely feel free to have a look at it. Real quick, existing data sources we support. You'll see there's quite a few that you've already added. So existing GraphQL APIs, whether it be also data sources, Athena and Cockroach, brand new, Snowflake coming up. And then we have a whole bunch of data sources planned. So a lot of really, really cool stuff. But as we know, anytime you're talking about data sources in GraphQL, everybody's just like, but when's like my database going to be supported? So we are working on it. Definitely hit us on GitHub because we are an open source product, or as I like to say, the pay me if you want model. So everything that I'll be talking about today is actually part of our open source product. You can run it anywhere that you run Docker infrastructure. And so as long as you are able to run Docker, you'll be able to run Hasura yourself. I'll be talking about stuff that's mostly, or I'll be using Hasura Cloud for the demo later on. That's just because it's like a really fast way to get going with Hasura. And in my opinion, it's the easiest way because, I mean, if you want to go K8 all day, like, good on you. But I don't, because I'm DevRel. I like to do cloud products. So that's sort of my background. And that brings us to the worst segue of the day. And that is a fake tweet here of, is he going to actually talk about subscriptions? Yes, I am. That's what we're doing right now. So we're going to go ahead and jump into it. And we're going to have a quick overview here. I'm assuming most of you who are here in this talk are aware of what subscriptions are because it's like a GraphQL conference. But if you're not, we have essentially this before and after story of what subscriptions are. So the typical API layer, API gateway model, you've got databases and microservices that you're trying to all bring into a single API for your client. If any of those services go down, you have this problem, right, where all of a sudden the actual gateway may time out. You're going to have a really hard time recovering from failure points. And so you have a somewhat brittle architecture working with the typical API gateway approach. Subscriptions allow us to basically solve that by using a centralized event source, if you will, that'll actually wait for processed events to be able to go ahead and execute behavior somewhere else, come back, update our data store, and then we can actually stream those changes real time. So whether it be the status of payment processing matched up with something like shipping delivery or shipping status, those are two different processes that maybe come in at different times, but we want to have the same listen to that event, if you will, and not have to wait for all of the API services to finish. We can say, tell my data store I made an order, and that'll go ahead and trigger off a payment flow, and that'll trigger off then a shipment flow. And I can just let my user know when those things have changed without having to poll, without having to do a lot of these existing real-time hacks that we've worked with in the past. So if you heard the key word there, we have event-driven architecture by now. Now there's a lot of books out there on this, but I really want to actually hammer on the point that this underlying ability to now work with event-driven architecture in a more robust way is frankly one of the features that makes GraphQL such a powerful thing to work with, because you have the ability to be able to fire off long-running processes parallel to the rest of your application data. So for product builders, this is a really, really powerful model to work with. All right, so why do we see subscriptions always kind of looking different from provider to provider? Why do we see one solution has it this way and one has it that way? And even in today's talk, we're talking about two different types that even Hasura provides itself. And that's because the specification for GraphQL doesn't tell us anything different. It tells us what actually needs to happen for subscriptions. It says that we need to have this a type of transport. It tells us that we need to have the data respond in a certain way, but it kind of leaves it up to interpretation after that. There's nothing else that we need to even worry about on how to actually execute this as a provider. So it allows for a lot of different bits of creativity in figuring out how does that work. Well, from the Hasura side, that's allowed us to actually kind of map this a bit more closely to something like Postgres events. And so we've been able to see a lot of success from that side, and we'll have a look at it in a minute. But one of the underlying pieces about subscriptions that's also unique in the GraphQL ecosystem is that queries and mutations, those are stateless, transactions. Those are things that we can scale really well by just adding extra clusters to our installs. But subscriptions are not stateless. Subscriptions imply there's something listening to the current status or the current data of an index somewhere. And so subscriptions become actually really, really challenging on figuring out how do you properly implement that in your system, as well as how do you scale this out in an effective way. So we're going to have a look at some of the patterns that Hasura's come up with to solve those, as well as some of these are also universal ones that other people have used at this point as well. So I want to talk about two primary types of subscriptions. And specifically, again, this is from the Hasura side because, again, it's the tool that I work with. You'll see that other providers have similar patterns, but we're talking very specifically about this idea of live queries versus streaming events. So let's have a look at what we mean by live queries. And live queries are very much about the state of a thing, right? So let's say we have this order. We've gone ahead and we've queried something with an order ID of 1. And we're able to see the status change across 3 different deltas. So we've got the status of XXX, YYY, ZZZ, and the locations also change as things go along, some kind of telemetrics data. Pretty straightforward approach. And actually, this model works pretty well. We were able to see this implement quite neatly by adding in just horizontally scaled numbers of instances listening in to these live queries. So if you've got 30 users listening to the same query essentially, and you want to start to scale this out, you can just dump more and more Hasura instances on top of that, and you'll be able to handle as much load as you want. In fact, we were actually able to scale this to 1 million live queries, like 1 million rows updated per second. So like, hats off to the engineering team behind that. That's actually pretty impressive. But but there were actually some problems that did come up with that, and that is coming from the key part of 1 million rows updated per second. Because the problem is that, yeah, if I have one object that I'm listening to as a stateful or as a state of a thing to be listening to, and I'm getting that returned, that's not really so hard because I can scale that out pretty well horizontally. But like, what happens if the state of a thing actually goes up? Like, my admin now is reading this thing. So it's not just me as a user wanting to see my 1 or 2 orders. It's now maybe BizOps wanting to see the 500 orders. And now if I'm actually having to pump an exponentially growing list of data objects, the size of that payload begins to grow and grow and grow. That's not a problem that I can actually solve for horizontally, because if I suddenly have thousands of records that I'm supposed to be somehow subscribing to the changed delta on, well, now we actually have a problem that's not solvable from a horizontal perspective by simply throwing more Hasuras at it. Well, that's where we talk about this idea of streaming subscriptions. And so streaming subscriptions, instead of listening to the state of a thing, they listen to the actual event archive of a thing changing. And so we can actually say that every time that there was a change to a specific row, we're able to now see just that update that's coming through. So we can say not just for items 1, 2, and 3, we can see a separate discrete event every time item 1 changed or item 2 changed. And we can set a very custom fine-tuned batch on that and say, we're going to allow 3 items per push to say, okay, item 1 changed again, and we have a new item 2 and maybe a new item 3, or we have just having a single batch. And this allows us to be able to really fine-tune control the shape of the payloads coming in. We can have these streaming events really fine-tuned controlled from the client to say, hey, I'm not wanting to get all 1,000 items right now. I'll handle that on my side. I just want you to send me the new events and not just send me the same 1,000 items over and over, even if none of that data actually changed. So what are some actual benefits of this approach? Well, you can use this to fetch very large amounts of data, and you can fetch all of that in a streaming manner. So if you've got things like a lot of messages, or you've got huge chat queues or whatever else, this allows you to throw as many events as you want at the thing and be able to actually get that data streamed to you in a very efficient, very streamlined way. So some of the hallmarks of Hasura specific implementation of streaming is that it makes the GraphQL calls very efficient, and it allows you to batch multiple streamings per consumer. So what we have architected on the back end is, let's say we have 300 people all listening to the same channel, we're able to actually group those on the back end, make one fetch to the database, and then stream those back out to the corresponding clients by listening in and batching these requests, which is allowing us to remove a lot of pressure off of our database, because a lot of times there's a lot of people listening to the same channel of something. And one of the best parts of this is that it still sticks with Hasura's auth-z predicate pushdown. And if you're not familiar with the predicate pushdown, basically what we're saying is Hasura, when it does its transformation of the GraphQL queries to its SQL queries, we're able to actually transform the request so that we're only grabbing the data that the user has access to from the database itself. We're not fetching everything from the database, filtering things down, and pushing it back down to the user. We're actually making very resource conscious and resource aware queries structured from the database and then giving it to the user. And these auth-z permissions are built into the streaming model. Whereas typically a queue type mechanism, it's up to the middleware layer to actually be able to filter out who has access to what. In this case, we're able to actually very specifically have declarative auth-z right on the data access pattern itself. And so the two big pieces then are we have the authorization, and like This is GraphQL land, right? So we're actually able to benefit from the same GraphQL relations where we can have the same row that's changing. We could go ahead and use that as a relational entry point and be able to take the data we're looking for from that and bring it down to our system as well. So we can say we have the full access and the full power of GraphQL available to us, which again is not something that a common queue management system might have available for you. So everything's perfect. End of talk. No worries. Everybody use Hasura. Oh, okay. All right. So maybe there are a couple of gotchas. So a couple of gotchas about streaming subscriptions themselves. One of the things is that you can only use a single column cursor. So you need to have a single monotonic ID that you're able to say, this is a sortable. This is the cursor that I'm able to use to identify from which point to which point I want to stream the events. And also there's no back pressure support. This is something that the client itself has to be able to maintain. It's actually in the specification that there is no ideas of hangups or sending back requests to the server in the GraphQL specification. There's no back pressure support from the server side. It's something the client actually needs to be able to support. So ideas of good monotonic IDs, big integers, so things that you can actually say will be guaranteed to always be scaling forward, up or down, but scaling forward, or things like dates or times. So timestamps are awesome for this, as long as you have it be unique enough. So these are some of the gotchas to be aware of. But I wanted to kind of talk about some of the differences of other things you may have heard about in the streaming land. So if you've heard of in the GraphQL ecosystem of the @stream, this is totally different. So what I want to say is that the big difference here between streaming events and the upcoming directive for @stream is that @stream is a server-side directive that is able to say we're streaming chunks of data at the server's discretion to the client to say how much data are we going to push and what's available and when. Whereas streaming subscriptions are configurable from the client. So we can say very specifically, okay, I last logged in at Thursday, last week, and I want to stream all events from that point to this client. Or I'm able to be very configurable about what size batches and what size chunks of data I want to fetch as a client, or be open to being receiving from the server. And so configuring that from a client side allows for a lot of streamlined behavior. So if we have a kind of a high level look, and I want to get to the demo here pretty quick so everybody has kind of an idea. If we get to the high level look at what the differences are then between these live queries versus streaming events, is that live queries are very much for stateful data, whereas streaming events are for events. they're for things that occurred. So is the light bulb on or off is a state. How many times somebody flipped that switch is maybe a useful information for janitorial services or somebody else who's wanting to know the usage of a space. So different use cases for when you would want to use the different kinds of data to be able to track what's actually occurring. So why care? Why care about using these? Is, well, it's easier to use for the client if you actually work with this kind of data. If you work with streaming subscriptions, you're able to be really fine-tuned about what data you're receiving, as well as how you're wanting to be able to fetch this. And then it's more performant. I mean, you're not sending massive amounts of data down the wire to the client who's listening. So this is something, again, that's very, very configurable and very, very helpful for people who are trying to build performant applications. Okay, that was the high-level fast version, but like it's not going to be great unless we actually can get a demo out of this and really kind of see it come into play. So I'm going to ask you all to be on your best behavior here, but go ahead and scan this URL here, and we're gonna go ahead and go to this little demo here, and I'm going to just pull this right up. And I'm going to have to drop out of mode here. So I'm going to put the URL in here and then go back to the slide. So I'm going to need everybody to go ahead and scan this code there if you can. So give you one more chance here to pull that up. And then if you head on over to the actual chat application, you're going to see that we can actually stream events now. So go ahead and, hey, Brian, Brian's first person in there. I appreciate it. You can see that we actually have the streaming events happening here. So what we've got going on is this is the GraphQL query. If you can see this here in the upper right corner, is you have the subscription, you have the actual initial value defined, you have the batch size defined, and the cursor size. And so this is the data we're looking for. And then we can watch the subscription actually change. So we'll see here that we have the batch size is 10. And then these are all the incoming events that are being pushed down to our server. So these are actually all new events and something that we're able to actually work with on a really effective way. So a pretty cool thing here to be able to kind of work with. I think it's really cool. That being said, I want to kind of hop back over here to the slide again one more time. And what we have is some more information on this if it's something that's interesting for you. This is where we actually have the blog article where we've written out everything about this demo. And you'll see everything that you need to that you'll want to kind of read about how we've implemented it, everything that we've done, as well as resources to the chat application. You can find all this on the Hasura blog as well. But yeah, this is basically the high level version of it. I am curious, Brian, how are we doing on time? Do we have time for one last demo, or are we getting tight? Somebody can respond to me there in chat.
We have about 3 minutes till our next presentation, so we can do a demo or take questions.
We gotta do Q&A then. So we need to go to Q&A, you're saying?
Pretty much. Although
okay.
Currently there are no questions in chat, so.
No, well, no, we can go to Q&A. So that was the last slide I have. I did want to mention that, again, one of the really awesome benefits about this is that you have the ability for built-in permissions. And so you can actually have that push-down predicate where you're able to say, I can very fine-tune, say, who has access to which data. So if you play around with it, it's really powerful. And speaking of playing around with it, like this is ready to go. This is production grade. This is not beta. This is not alpha. This is actually live. This is inside of the both versions. And if you want to have a test with it today, sign up for Hasura Cloud. Totally available. We have a free tier, and it's all in there. And just go play around, have fun. We have a lot of content. I've got a recent 20-part video series on working with Hasura itself. You can have a look at that on YouTube. But yeah, questions. I think we have like 1.5 minutes.
Yeah. So the very first question I think is an easy one. To reiterate, you said that they could deploy this anywhere that there's a Docker setup, right?
Yeah.
Yep. So not just with Hasura Cloud, although as you mentioned in DevRel world, I'm with you. Cloud services is great. So yeah, so available for Docker. I have a question actually.
Yeah.
What are best practices around like mixing and matching these patterns? Should you ever mix and match them? Is it a problem too? Because sometimes you need stateful things and sometimes you don't.
So in the chat application, there was an online status as well as then the actual stream of events. So I would say in the case of the online status, you could just totally have that be a stateful search, right? You could just see, okay, give me everybody who's currently online. So there's a number of cases where you potentially want to do one versus the other. The demo that I was going to do as an alternative has like a canvas, which is a stateful thing versus the stream of changes to the canvas. But it really comes down to the application you're trying to build. So again, if it's a stateful thing, what is the status of the lights in the building versus how many times were the light, like when was the light turned off? When was the actual sign off time? Things like that. Yeah.
Gotcha. Great. Well, no additional questions in chat. So Jesse, amazing job with the cold. Great job. I hope you feel better.
Appreciate it.
And thanks so much for sharing with us today.
All right. Thank you.